but we are doing things differently. We understand the failure modes, and we have a testing facility, and we run through all these failure modes, and we deeply understand the signals associated with these failure modes. And this allows us to build algorithms that only work on a device. And then you only have to exfiltrate when something's wrong. Just several small packets, something's wrong in this location, this is what went wrong, you should check it out.
Hello everyone, welcome back to another episode of Clean Tech is the podcast. This is episode 29. We certainly hope you enjoyed last week's conversation. The second part of our conversation with the EV fast charging company Electric Fish is one of my favorites to date. But we are happy today to bring you our discussion with Tim Barat, who is the co-founder and CEO of Gridware. Gridware is a power transmission IoT company. So the transmission lines that you see kind of all over where you drive, they have an IoT company that puts these devices to help track some different things and aspects about those power grids and make them safer, as well as help reduce response time for outages. So really interesting conversation with Tim. His background to me was quite interesting, how he ended up starting in the utilities space as a lineman and then eventually kind of founded this company. So really, really fascinating conversation. I hope you enjoyed as much as I did. But before we do get into the show, I do want to mention, of course, NextWave Partners, who makes this possible. NextWave are experts in the talent acquisition and recruitment across the ClimateTech, renewables, and ESG spaces globally. So if you or your team are looking to grow, maybe you're looking to make a career change, please do consider reaching out to their team. You can do that through their website at next-wavepartners.com, or you can also reach out to one of their consultants directly through LinkedIn. And if you go to the team page, you'll be able to find a consultant on their website who operates in the space that might make sense for you. So without further delay, let's get into the episode. All right, welcome to the podcast. Tim, how are you doing today?
Good. Thanks for having me, Silas.
Yeah, thanks so much for coming on. I'm really excited for this conversation. I think the topic of IoT is something that we haven't really gone into too much in the podcast yet. So very excited. So for starters, could you just give us a bit of background on yourself and maybe some of your backstory and your accomplishments thus far?
Yeah, absolutely. I'm a co-founder and CEO of Gridware now, but I actually dropped out of high school when I was 15, and I ended up working on the power grid as a lineman. I then immigrated to the US about 9 years ago, and I got married. My wife didn't want me to work on the grid anymore, on high voltage. So I went back to school. I studied electrical engineering and computer science, both my undergraduate and graduate degrees at UC Berkeley. I noticed the lack of academic research for grid modernization, especially from a field perspective. And so I began contributing as much as I could and thinking about ways that we could operate our grid a lot better. It's challenging when you have to maintain such large amounts of infrastructure, especially with a diminishing workforce. And in 2018, when the Camp Fire happened and 83 people died, I realized that what I was thinking about and what I was working on could have stopped that fire from happening. So I decided to found Gridware to bring this technology to market as quickly as I could.
Okay, got it. So could you talk to us a little bit more then about what Gridware does specifically, and just kind of give us the very basic explanation so that anybody listening, regardless of their technical background, can understand?
Yeah, absolutely. So Gridware builds hardware and software which can detect when and where the power grid will fail before it can ignite catastrophic wildfires. And we do that with a hardware device that we've built to permanently attach to utility poles, essentially putting a lineman on every single pole. Because right now, linemen spend a lot of time searching for faults instead of fixing them. There's a lot of signal and a lot happens when something goes wrong on the grid, but you have to be in the right place at the right time. And unfortunately, you're never at the right place at the right time.
Okay, got it. So maybe could you talk about, I guess, I'm kind of curious. I actually have relatives who are linemen. So I'm kind of curious to talk about some of the typical things, that the challenges they face, and how maybe some of this can obviously, first of all, mitigate maybe the risks that they face. We can talk about the talent issue later, but I want to talk about the risks first.
Yeah, absolutely. It's interesting because this is actually one of my motivators when I started thinking about this issue. So when we go through our apprenticeship, we get taught every time before we climb a pole to hit it with a hammer. Listen to how it sounds. And there could be heart rot, termite damage within the pole. We're climbing up 45 foot of the ground. Is it going to come down on us? And so what happens is when you hit a pole with a hammer, it has a specific sound. And that sound is significantly lower if there's internal heart rot or decay or something wrong. And this is crazy because this is still how utilities determine the integrity of their poles. And it's prone to human error. What if you hit it in the wrong spot? Or what if you hit it in the incorrect way? Being a lineman is really dangerous for many reasons, not just related to electricity, but also being high above the ground. And so I began thinking about this. Maybe there's something that we can do with sensors that would be a little more accurate. And instead of having utility go out to inspect their poles every 10 years, well, we would be able to understand how the poles were changing and predict when they would fail so that we can better manage the assets. Right now, most equipment on the grid is operated to failure, and we have no choice. And so that's one challenge, but there's also many other challenges. When something goes wrong, there's an outage, you might have 1,000 customers offline, you get a call from dispatch, fix it. And that's pretty much all the information that you get. And so you start in the middle, you divide and conquer, you build up a general intuition about your infrastructure in your territory. And often you know exactly where to go, or to some degree know where to go. But a lot of the times, these are transient problems. You could have 1,000 birds sitting up on the power lines, and then a truck drives past and beeps the horn, and they all fly off at once. And that force, the collective force, causes the power lines to clash with each other. And you trip the breaker, there's an outage, and you don't know where that happens. So you kind of drive back and forth up the circuit, and you don't see anything. There might be a little bit of black charring where the clash was. Sometimes you can see that, but really you have to be a detective most of the time. So these are just some of the challenges that we're trying to help solve.
Yeah, it makes sense. I think it's some of these. I find it fascinating. My dad is a carpenter, so I grew up with this old school kind of the trades type of mentality. So it's interesting to see that just technology in these spaces to help improve them. I think sometimes tradesmen tend to just want to keep their trade the same way it is because it's tradition, which is understandable. But obviously there's a lot of benefits, especially in a space like this with the high danger. So I'm curious to talk about now the financial returns, right? So can you talk about what is the cost of implementation for a utility? Is it typically that these are retrofitted? I'm assuming it's probably best to install, as the transmission lines are built. But could you just talk about the cost of implementation, typically the time it might take for a certain section to redo this, and then what the financial returns can be kind of in the long run? Really broad spectrum here.
So I'll start with the latter, right? When we look at the campfire and how much it costs us, over $16 billion worth of liability just from one fire. And since then, 2019, 2020, 2021, we've just seen more catastrophic mega fires, all ignited by the power grid. In fact, 9 out of the top 20 catastrophic fires in California were ignited by the grid. But then when you start to look at how they're responding to that, which is with power safety, public safety power shutoffs. So during periods where there's elevated winds and high fire risk, utilities switch off the grid because they'd rather have an outage than a fire. And that's also expensive. In 2019, we had a 3-week-long outage. For every day, there was $100 million in economic impact. And so this is something that regulators, ratepayers, utilities can all agree is a very, very big problem. And that's why now the federal administration has just signed in a $1.2 trillion bill that's going to go to infrastructure. I think the challenge is that money is not going to be spent in the right places because there isn't any data to make those decisions about where you do deploy that or very little amounts of data. And so we really want to help assist to understand causality. Generally, when something goes wrong, we know about it. Sometimes we don't. In the fire, in some fires, you'll have a tree lean up against the power line and it'll be there for a couple of days before anything happens. And you have an ignition, and then you only really know about it once the fire is emitting enough smoke so people can see it. And it's too late. But generally, when something happens, we know. It's a little bit more difficult to understand where, but we don't know why. This remains elusive. What's the causality of these events? What's interesting is if you have, our office is located in Walnut Creek in California, and there's a mountain range separating Walnut Creek from the bay. If you have a pole installed right next to the bay where there's high humidity, and you have a pole installed in front of our office where it's a more moderate climate, more dry, they both have the same failure curves, and the decisions are going to be made about replacement exactly the same, even though they have entirely different environments. And so this is what's going to happen with the infrastructure bill is all that spending is going to be based on very sparse data. So to kind of answer your question quantitatively, right now, utilities in California, they go out and they do a pole inspection every 10 years. That costs around $200, sometimes less, depending. Maybe out in Wisconsin, it's a little bit cheaper, but generally between $100 and $200. What we want to do is we want to partner with organizations that do these pole inspections to create enough value for the utility such that it doesn't cost them any more to install this device while they go out and do the inspection. So do the inspection as you normally would, install the device, and everything still costs the same. And then afterwards, the insights that we begin to derive will be extremely valuable to the utilities, and we'll build a business model around that.
Okay, got it. That makes sense. So are there, is it typically only going to be valuable for the utilities to implement this across, massive sections of their transmission lines, or can there be a lot of value in just doing, starting small to start reaping the benefits right away? Because I'm not sure what the process is. Maybe you could speak to that with utilities, public utilities, getting these things approved to do these new technologies. Could you maybe speak to that process?
Yeah, so the utilities have to be prudent managers of their assets, but they also need to be prudent managers of the funds, especially municipal utilities or smaller utilities, right? These are ratepayers that are trusting them with money to deploy technology. So they're generally conservative. And the discussions have always been, we invest in technologies that are proven. What's the definition of a proven technology? Well, it's a technology that has been previously deployed at exactly the same scale that you are seeking to deploy. So how do you get 10,000 devices out on the grid to prove it without having had 10,000 devices out on the grid? Where we sit right now is at a very unique position or opportunity where this problem is so dire and has such catastrophic implications if it's not solved, that utilities are willing to take risks that they previously weren't willing to do. And that's why we've had a lot of traction with the utilities in California who are willing to try us out. And we can create incremental value. As an example, if you have a circuit, there might be 100 poles. and there's a recloser. Recloser basically monitors the power signals for when something goes wrong and then cuts the power. Utilities in California now operating these reclosers at what they call fire mode, or very sensitive. Any little tiny thing, even if you have like mist roll through and there's a little arcing, it'll trip. It's not a problem. It doesn't cause any fires or anything, but it will still trip. Then they have to go out and they start at the first pole and they go down all the 100 poles to make sure, and that can take like 3 or 4 hours to do before they energize. But our system installed on every single pole across 100 poles on that circuit, we'd be able to tell them exactly where it happened. And so we can have ROI very, very quickly, especially during these months of transition from summer to winter. And there's these weather events.
Okay, yeah, that makes sense. So what about, how do these devices work in terms of, do they have to be, I guess, is it possible to implement this technology where there's not really good internet access? I'm not sure of the technology behind that and how that all connects and how the data is collected and sent back to some centralized HQ.
So we've placed a lot of emphasis on local processing on the device. We've seen huge capability enhancements to the microprocessors. You know, I'm wearing an Apple Watch right now, and it can do a lot of things, including measuring my heart, and we're taking a lot of those advances and applying it to this problem, where you can derive these insights without having to exfiltrate a lot of data to the cloud. And this is the big challenge, because when you're any sensing unit out in the field, right now, the chosen method or the most popular method of doing things is, let's put dumb sensors out into the field, exfiltrate a lot of data, and then do the processing, run it through a black box on the cloud. But we are doing things differently. We understand the failure modes, and we have a testing facility, and we run through all these failure modes, and we deeply understand the signals associated with these failure modes. And this allows us to build algorithms that only work on a device. And then you only have to exfiltrate when something's wrong. Just several small packets, something's wrong in this location, this is what went wrong, you should check it out. And when you switch to this mode of operation, you could explore other ways of communication instead of without having the necessity of cellular communication. You can bunny hop packets back through the sub-gigahertz spectrum, and yeah, they talk to each other back to a unit that is either connected over cellular, over satellite, or directly connected at the substation.
Okay, got it. That makes sense. So what about I guess I'm curious with the data that you're collecting. So it's obviously triggering issues, right? But are there any aspects of the data that are being collected that can be sent back to the utility to maybe potentially help the transmission planners? Because in recruiting, I work with a lot of transmission people, and obviously running power system studies is a humongous it's a huge workload within utilities. I'm curious if there's any solutions that you're at least doing now or potentially going to be helping with in the future with regards to that.
Yeah, great question. This is a huge emphasis, even from the federal level. The Department of Energy is investing a lot of money into this very, very direction, where to enable us to make better decisions about how you prioritize outages. For example, you could have a circuit that has 50 homes with solar and another circuit that has one old gentleman watching his TV at the end of it. How do you prioritize? You need to be nimble and incorporate that data. And we're thinking about this too, because we want to justify placing these devices out on all of the poles. But then once they're out there, there's many different things that we can do. And so, yes, we are able to exfiltrate health statistics, weather, we can sample our solar panels, and depending on the voltage in the solar panels, you can tell if there's clouds, and you can observe how clouds are moving over the grid. And this is a big deal when you're talking about, distributed energy resources and how you manage them. So there's a lot of opportunities, and that's why we've really placed emphasis on making the units flexible. We can update them over the air with additional applications that we identify over time.
Mm-hmm. One thing I'm curious about too is, I don't know a lot about how utilities operate, but is it required for them to do any upgrades or create any specific databases to collect and process these things, all of this data later on for future use? I know you mentioned with this, this spending bill for infrastructure, I'd be curious how this data could also be valued for the utility in other ways. Maybe that's bringing the data in and then being able to pass it to some, central processor to find ideas on how can we make sure that we're spending money in the right way or whatnot. But I'm just curious about the usage of the data. Is there any infrastructure that utilities tend to have to build to collect and house this? Just along those lines, I want to understand more about that aspect.
The utilities, some utilities, not all utilities, remember, they tried to keep the rates down as much as possible, especially the smaller utilities. And we're starting to see some utilities invest in teams that do data science and able to aggregate and derive insights. There are also a lot of companies that sell products to utilities and aggregate weather data, news data, satellite data to derive insights. And then, you've got energy trading platforms. There is a lot of opportunities, but it's a balancing act, because the utility, at the end of the day, needs to keep the lights on and keep the rates down to a manageable level.
Yeah, to me, it seems as though if this technology is implemented, though, generally speaking, that can reduce the rates hypothetically a lot because of all the money that's spent on repairs or wasted man hours, for example, or you mentioned the liability payment. So I think it's very interesting. This is to me, this is exciting. I'm curious to maybe understand from the perspective of starting the company and founding it, what kind of technologies and resources were available that you could just kind of patch together. What was the process like? I'm genuinely curious about the manufacturing process for these things, because I feel like ClimateTech has a lot of technology solutions, but there's also many physical solutions that need to be created. So could you just walk us through that process and maybe some of the things that stood out to you and your learnings there?
So to solve this problem, we weren't able to just put together things that we could buy off the shelf. It really required us to do deep R&D and disciplined application of the scientific method to push the technical boundaries. So we had to put together an A team for that. And in terms of manufacturing, well, once we've had the several revisions of the PCB, of the firmware, and also designing the enclosure to be robust out in these extreme environments, then we've worked with the contract manufacturer to get that manufactured. And right now, we're dealing with, on the order of hundreds of units. And so we've selected a contract manufacturer that can scale, and that's been our approach.
Will the costs come down quite significantly as volume increases?
Yeah, absolutely. So at this scale, we were at the border of should we injection mold our enclosures or not. We decided to injection mold them, and we had to pay a significant amount of money for the molds. But now every time you shoot an enclosure, it generally costs $10 to $15 instead of $700 But if you amortize that mold, the cost of that mold over how many units we're manufacturing over the past 3 to 6 months, they're expensive. But as you scale, it goes away.
Yeah, that makes sense. I think to me that this problem is something. I'm sure you have some insights on this in general, but just the idea that a lot of companies focus on the tech issues because they're quicker to solve versus the actual physical technology, requires a lot of R&D and these upfront sunk costs. I think it's an interesting dilemma that we face, but I'm excited for the future of it. Perhaps curious to shift maybe to the broader IoT sector. So with whether this is, your IoT devices, your specific technology, or just more broadly speaking, could you talk to us about how IoT will change day-to-day life for most Americans, for example?
Great question. 2 key achievements changed life as we know it over the past 2 decades: the internet and computational ability to process large amounts of data. So this transformed countless numbers of industries, but sadly, not energy and utilities. So we want to change that by extending internet technologies and this modern computation to the grid. And this will allow us to meet the 21st century grid goals: decarbonation, sustainability, reliability challenges. And we can do that now with data-driven decisions.
But are there, one thing I'm curious about is with there being physical technology enclosed in these devices, to what extent are you able to update, I don't know if the proper term is the internal software, as you get improvements? How does that work? Is it going to have to be that just you go to the device and actually change it out with something new, or is there going to be to some extent increased capacity or capabilities that can just be updated wirelessly, whether that's driving next to each one or maybe some kind of update that's sent out?
So we can update our devices over the air. We don't have to be anywhere near them. We can do that remotely. Obviously, there are limits to the capability of the processing and memory, but we've left sufficient room to be able to do a lot of very interesting things that we hypothesize in the future.
Got it. Okay. Another topic I think that comes up a lot in conjunction with IoT is cybersecurity. So could you talk a little bit about the cybersecurity risks of IoT devices being everywhere at some point, especially tied into our grid, and how your technology is mitigating those risks, or what you just see broadly speaking in the market happening?
Great question. Going into this industry, we knew that IoT had a really bad cybersecurity reputation, but also we knew that we had to do something differently because we work directly with critical infrastructure. Basic cybersecurity competency is actually something that we screen for in all of our hardware and software engineers. It's because we want to have a culture of building secure systems ingrained from the very get-go. Many of the vulnerabilities that have been widely publicized, in the media and in the IoT industry, it's simply due to the fact that basic cybersecurity best practices are not being followed. For example, engineers leave hardware or software backdoors, which they use for development or debugging. They leave them wide open, even once the products leave the lab and they start being manufactured and then go into production. But at Gridware, I think a great analogy or the way that we think about it is we've locked all the doors and windows, we've thrown away the keys, and we only leave the way in and out is basically a fully encrypted and authenticated chimney, if that makes sense.
Yeah, okay, that makes sense. One other thing I'm kind of curious about is your take on, I don't know if you would classify this into the education space or just generally. I know utilities tend to be, at least when I've worked in recruiting, a lot of times they're considered more bureaucratic. Obviously have more structures in place. Do you see any kind of shift happening in terms of getting maybe a little bit more entrepreneurial people inside of these utilities that really, even though they have a responsibility to keep rates low, they have a really huge responsibility to help changing the grid and updating things? I'm curious to see what you think is being done. I know California tends to be ahead of the curve on some of these things. So I'm curious to see if there's an education program that's helping to get more entrepreneurial minded people into utilities, and maybe just some of the mindset shift that's happening there.
So we were really fortunate to receive a lot of support from UC Berkeley. We were a part of what's called the Citrus Foundry, which is an incubator that spans several of the University of California campuses, and they helped us to establish Gridware. I believe the UC is actually leading the pack with a large emphasis on entrepreneurship and research, which actually has societal impact. And this extends to utilities. In fact, Citrus stands for Center for Information Technology Research in the Interest of Society. And what has happened is with this strong emphasis on educating students to become change makers, that's what UC Berkeley has at its core mission. We're working on planet scale problems with one-of-a-kind people. What we've seen is entrepreneurship and startup innovation really succeed and enjoy a lot of success and disrupt industries. And this is like a classic example, but Tesla has now disrupted the automotive industry. And this is also happening within utilities. A lot of the new technologies that are making huge impacts within utilities have come from startup innovation. And so when you have decision makers that are more pragmatic, more conservative, facing real data about how startups have come in and delivered, they're starting to be more receptive. And the people that are on the forefront that just want to be involved in technology are starting to recognize that industries, not just utilities, but industries that are dominated by conservative, pragmatic decision makers, have huge opportunities for optimization and real impact. And instead of working on challenges that have marginal or incremental benefits, it might be consumer technology, building the new smart speaker in your home. You could do the exact same amount of work, but save lives. That's what we do at Gridware, right? And we come to work every day, and our metric of success is how many lives have we saved.
Yeah, that's interesting. I mean, I think that's that mindset that is important. I'd be curious to maybe dig into this just generally a bit more in terms of what you've learned in founding Gridware. Kind of, could you talk about some of the biggest things that you faced personally, that you came through the challenges of, or that you learned, and maybe talk a little bit about how you lead your team? Because I think something I've noticed that I would be curious to hear your perspective on is leaders in this space, people who are being tech leaders with these new technologies and helping implement these things towards mitigating climate change. I think that the mentality behind what they do is very different. It's not just they're not just commercially focused. So could you speak about your experiences and what you've learned?
Great question. I'd like to share that I'm an entrepreneur out of necessity, not out of choice. As an example, or kind of what served as an inspiration to me, was Impossible Foods. I've been a vegetarian my whole life and never really had any options when I go to restaurants. And then all of a sudden, Impossible Foods raises money from venture capital. And now you have plant-based meats all throughout the US. And that's huge impact. And that's really one of the reasons why I decided to start Gridware, because instead of going along with my plan to go through a PhD and then go into a national laboratory and maybe 6 to 10 years before any of my ideas proliferated onto the grid. There's an opportunity for us already within 12 months to have our technology actually out in the field providing value to utilities. And this is why I decided to start Gridware, not out of choice, but out of necessity. And so this is really extended out through all the people that, at least in our organization, and I think people that in general work at small startups or even larger startups that are working on problems that are planet scale, have that type of opportunity for impact. We really coming to work not to enrich ourselves as a primary objective, and that's really special.
Yeah, and what have you learned about, I guess maybe through the hiring process, or just generally speaking, finding other people that kind of fit into the mission? Have you noticed any specific kind of insights that you felt were inspiring, or just generally that you didn't expect?
Our recruitment pipeline's been really strong. People resonate a lot with our mission and what we're trying to accomplish. Everybody wants to get in on the action. And most of the people that are on our team actually self-selected and reached out to us, because it's a rare opportunity to wake up every day and go to work to save lives. So I think, one of the things that we did very early on is establish the values of the organization. And those values really center around humility. And when people really, truly want to solve this problem, it really shines through the interview process. And yeah, that's probably the biggest insight that I've gained is that if an individual is able to understand their weaknesses and their strengths and be humble and acknowledge those things, it really creates an environment where, it creates an environment of excellence.
Yeah, I mean, I think that makes sense. I think that I've had this discussion with some of the people a little bit older than me, who tend to think that working for something that motivates you isn't as necessary as they see it, right? I think I find it very necessary. I went through that journey myself, but now that's interesting to see that there's definitely a lot of people interested in these problems that maybe, on the surface, I don't think thinking about grid IoT technology, it doesn't seem that sexy, but it really obviously has a massive impact on people's lives. So I can assume that that's probably even more close to people's hearts in California, where these things happen on a too often of a basis.
Yeah, and people have this perception that grid technologies are a dinosaur-like and not exciting to work on. But the opposite is true. So the people that do approach us, maybe they don't even know this, but they very quickly come to realize that to really innovate on the grid and to solve the challenges we're up against requires us to work and utilize on state-of-the-art hardware and software. What we're building is not something that you can just put together by buying things off the shelf.
Yeah, that actually brings me to another question I'm kind of curious about. You might have to give us a bit more context on your background, but you obviously started out doing, actual lineman work, right? So you became acutely aware of the issues faced. Did you have a technical background to say, hey, besides knowing the issues, I also have the technical solutions to figure out problems to these? Did you have those two paired together before you decided to launch on this venture, or did you have to go seek out a partner to help you figure out the technical solution to what you knew to be the problem?
So I knew what the problem was. I didn't understand anything about the technology that would require to fix that problem. And that's great, because a lot of engineers develop a solution and then look for the problem that it could solve. But I really came at this understanding what I wanted to achieve, not really understanding how I was going to do that. And, having over 5 years of education in electrical engineering and computer science, after you know the problem, really allows you to select the courses that you take, and really incrementally, you get to spend many years thinking about how you solve this problem that you want, rather than developing a broad toolkit and then thinking, all right, what's something cool that I can build it, and then try to find a problem for it to solve. It very much happened differently for me. And so having that acute intuition, then going to school and studying a very technical discipline, electrical engineering and computer science, really equipped me with the tools to start thinking and explaining what I just intuitively knew, right? When you hit the pole with a hammer and it sounds different, as a line worker, you just accept that. It sounds different. And then you don't really dig into why that is happening. But then you go and you take 3 semesters of physics and a signals and systems course, and then you start to understand, well, what's actually happening is there's a symphony of vibrations flowing through all of the different molecules within the structure that, it has a different mass and a different stiffness, and it has its own natural frequency. And no matter what you hit it with, it's going to have that same sound. And you can explain that mathematically. Then you can start thinking about, well, how do I replicate that with technology? And this has really placed me in a very unique situation to be able to not just have that intuition, but then also the toolkit to explain things mathematically, rooted in science, and then extend that vision to people that are much smarter than me on my team, that can take my ideas and take it to the next level.
This is extremely interesting to me. This idea that you had some direct experience before going into university, and then it allowed you to focus. Do you have any thoughts, generally speaking, on kind of the education system and how individuals who are motivated to solve some of these climate issues, how they might approach things in a non-traditional way that could be, to some extent, replicating the way you've done it, or just generally speaking, if they are going straight out of high school into university, are there some things that you'd recommend them to think about? Or to me, this fascinates me that you had some exact experience so that you were able to apply as you were learning the knowledge theoretically to some exact problem, rather than, okay, here's knowledge and I don't know where I'll apply this, but I'll think about it. Could you talk about that and your thoughts on that space and how we might improve as a society?
I think it would be difficult to say, all right, after high school, go do a trade or go out into the field and do something for 2 years and then go to university. That would probably get a lot of traction. I think it would be great for society. But what really interests me is having that engagement between engineers and people that are out in the field, especially in these industries, blue collar. So kind of creating these opportunities for collision where you have blue collar people or people out in the field really interacting with engineers. I think that's the most promising opportunity here. And I think blue collar workers would have an interest in further training, and there is an opportunity there to facilitate additional training. I think the community college system that exists here in California is amazing for that, and kind of requiring base courses for blue collar workers that have an understanding of basic mathematics or even coding. Coding is just everywhere now and will continue to proliferate even more. And so, personally, I think absolutely every single person should take at least one coding class. Even if they don't end up coding, it just provides additional framework or structure into how you perceive the world, how you make decisions, and that comes down to how you spend your money, just general decision making in general.
Yeah, that makes sense. I think that it kind of plays into the idea of, a CEO, for example, may not know, he or she's not going to know the nuances of every operation, but is going to have probably a high level understanding of some of the things so that they can know if they're being bullshitted or not, right? So I'm curious, maybe one kind of final thing, given that your experience is essentially in this way, to people who maybe are trades folks who have worked in a trade, who understand some certain problems and who have a passion for helping improve those, especially as regards to the climate crisis. What are some of your pieces of advice these people, even if they've been in the industry for a long time, they may not have in-depth technical knowledge about the actual solutions, but know the problems? What would some of your advice be to them?
I remember when I decided to go back to university, it was one of the hardest decisions that I ever made. It was really scary. I had set up my life, I was comfortable. And when you know and you have experience, you know what you're doing, and you go to work and you have that flow, it's very comfortable, and you would really enjoy that. And it's difficult to put yourself out there and start again. I remember the first day when I sat at a desk in university, and it was such a foreign thing to me, probably the most foreign thing that I've ever done. Just you don't sit at a desk ever. And so I kind of slid myself into this, it has the desk and the chair as one unit amongst all these people that were so much younger than me, and then listened to a lecture, and I couldn't believe it. And it was the greatest decision that I ever made in my life. And so if there is even an inkling down there that within that education would be of interest, I am almost certain that there are problems that you will be able to solve, that you have unique intuition into, that somebody coming out of high school won't have. And so you have immense potential to have impact. But I'll also kind of speak to the engineers that have come out of high school and have gone directly to university. We generally tend to just interact with other engineers. If you're in college, you stay in the engineering buildings and I don't know, nerd out as you would. But I would encourage people to go out and spend time with people that you wouldn't usually. Have dinner with people that work out in the field, or go to or take courses that are completely irrelevant or unrelated to what it is that you're doing, because then you'll have the opportunity to connect with real problems that people haven't come across, engineers haven't come across in the past. So yeah, that's one piece of advice, 2 cents.
Yeah, I mean, to me, that's fascinating. I think the idea that you just mentioned at the end there is, of encountering things that you wouldn't typically encounter if you stayed on your path. Because if I look at it, if I understand correctly, most technical advancements have been kind of correlations drawn out of typically undiscovered or things that weren't looked at a certain way, right? But after looking at it from a different lens, you're able to see it a different way and to see a possible correlation solution. To me, this whole idea of taking themes and putting them together is something I'm so super fascinated by in my life. But no, I really appreciate this. This has been very interesting. Are there any final closing thoughts you wanted to offer, or just kind of things that you're really excited for the future of ClimateTech, of the grid, whatever it may be, just kind of things you want to close us off with?
Yeah, I think what is most important to me is that, kind of doing a call to action for people that are out there and that may be thinking about moving into working on challenges on the grid. What we're seeing now, or what we're observing, is an opportunity for us to tackle climate change, and yet the fragility of the grid is being weaponized against the migration to clean energy. I was reading something the other day where a description of COP26 that happened. There was an example given that it's like everybody's standing on a railroad, and a train is coming to hit them all, and they're all trying to incentivize each other. I'll give you $5 if you jump out of the way. I'll give you $10 if you jump out of the way. We need to jump out of the way. And one of the biggest problems is grid reliability. And I just encourage people to start thinking about the grid and how it's the very fabric and foundation of our society. We are completely reliant on electricity, and increasingly so.
Yeah, I think that's interesting. I feel like definitely people listening can possibly get involved too with their local governments and different, maybe utilities. I know for sure as soon as I'm done here, I'm going to go reach out to the mayor of my hometown and ask her to bring this up, because she's very good at looking at these things. So very interesting. I really appreciate you coming on and looking forward to seeing what you guys continue to do. And we'll have to have you back on the podcast again in the future.
Great. Thanks so much, Charles.
Thank you guys so much for listening today. I really hope you enjoyed the episode with Tim. It was such an interesting conversation for me to have with him, so I hope you enjoyed it. Please, of course, if you or someone you know works in this space, do share this episode with them. Obviously, there's a lot of financial savings to be had here, and just it's a very clear reason to adopt this technology. So definitely share it with somebody who could find this valuable and help adopt these cleaner technologies that will help generally make the world a better place, help reduce waste, etc. So in the meantime, if you are looking to stay more engaged or get more involved, please, you can feel free to join our Slack community. We always appreciate reviews on Apple Podcasts to help bolster the reach. And of course, feel free to reach out to Tim on LinkedIn, or you can also send me any questions you have on Twitter. You can support the show and of course sign up for the newsletter, which we're just finishing off the end of a 30-day challenge to help people adopt more sustainable mindset through daily tips on being a little bit more sustainable. And then, of course, big thanks to Next Wave Partners again for making this episode and this entire show possible. And a quick teaser also for next week, we will be speaking with Josh Keister, the president of Resilient Power. This is a really, really interesting technology that they've developed. It's for EV charging, and they've just recently actually closed a round of funding with a past guest on the pod, Craig Lawrence, who's him and his firm, Energy Transition Ventures, along with Amazon and a few others, invested in this company. So I'm really excited for that show. That'll be coming out on Thursday, and we look forward to seeing you there. The link to the episode with Craig will be in the show notes as well, so if you want to listen to that in the meantime. But other than that, we will see you next Thursday on CleanTech is the Podcast.